Assalamu alaikum wa rahmatullahi wa barakatuhu, dear students. I welcome you all within this online lecture series after a gag of almost 5 or 7 days as we were celebrating Eid al-Adha. Coming to our point, last time, let me recapitulate what we discussed in the last time, dear students. Last time we're talking about symbols of elements. Regarding the symbols of elements, I gave you some basic concepts regarding the symbols of elements, why we represent elements by their respect to symbols. We discussed alchemist symbols like these symbols, and I told you, dear students, what actually this alchemy is all about. We discussed those things actually. Coming to today's topic, we are going to discuss Dalton symbols. Firstly, you people should remember and should keep in your minds that every single element in periodic table is represented by its respective symbol. For example, we have 118 elements known. As far as our periodic table is concerned, we have 118 elements known, and every single element is represented by its respective symbols. Now the question arises, somebody will pose your question that why we represent respective symbols elements by their respective symbols. The only funda behind writing the symbols of an elements is to make their study to make their study to make their study systematic and easy, and it becomes easy for we people to write or to remember the elements. So somebody will pose your question that why we represent elements by their respective symbols. It's only to make their study systematic and easy, and it becomes easy for we people to write or to remember those symbols. And third point regarding this, I can say why we represent elements by their respective symbols is that's why this periodic table is used as a teaching aid in schools and colleges, so that students will remember these symbols, I can say, very easily, my dear students. So now today's topic is Dalton symbols. Let me tell you people before discussing these Dalton symbols. Last time I told you people, dear students, that some elements are named by the name of their discoveries or to honor some people or places. Mark my words, dear students, what I am telling you, kept it in your minds. Some elements, as far as our periodic table is concerned, you people will see, dear students, that some elements have been named after their discoveries or to honor some people or places, dear students. For example, we have let me give you a simple example. We have Americum. It's after America. We have Einstein. America is a name of place. America. Now Einstein was a scientist. Einsteinium. That's why I told you, dear students, that some elements have been named by the name of their discoveries or to honor some people or places, like Americum, like Einsteinium. Einsteinium, dear students, or Nobelium, or Cerium, etc. But nowadays, as far as modern chemistry is concerned, now the International Union of Pure and Applied Chemistry, known as IUPAC, approves names of elements. I'm talking about during ancient times, elements were named by the name of their discoveries or to honor some people or places. For example, I gave you the example of Americum, Einsteinium, Nobelium, Cerium, etc. Now the International Union of Pure and Applied Chemistry, known as IUPAC. Look, dear students, IUPAC. Sorry, so IUPAC, IUPAC. Now, International Union of Pure and Applied. This is international. I for international. International. U is Union of Pure. P for pure. A for applied. Now C for chemistry. So now IUPAC, that's International Union of Pure and Applied Chemistry, approves names of elements. Dear students, mark my words. Now we have Dalton symbols. Dalton symbols. The symbols for some elements as proposed by the Dalton are here. When he used a symbol for an element, mark my words, dear students, he also meant a definite quantity of that element. That's one element, atom of that element, dear students. Mark my words. What I am telling you, kept in your mind that when Dalton used a symbol for an element, he also meant a definite quantity. Mark my words, definite quantity. Definite quantity of that element, that's one atom of that element. That's one atom of that element. So Dalton proposed some symbols for elements. Mark my words, 118 elements were not known at that very time. I'm talking about ancient times. Dalton symbols. Presently, we have 118 elements, and every single element is, I can say, every single element, dear students, is represented by its respective symbol. Symbols, I'm talking about modern periodic table, dear students. But during ancient times, periodic table were not known at that very time. So, Dalton symbols. This is hydrogen. Hydrogen was symbolized as like this. If someone was in a state to remember this hydrogen, it was, I can say, obvious for that person to remember the hydrogen like this. The circle, and in circle we have one dot. It's a symbol used for Dalton, used the symbol this for hydrogen. Second, carbon was represented like this. It's a carbon. There's oxygen. This was symbol for phosphor like this. It's a circle and like this. The symbol for phosphorus. The symbol for sulfur, symbol for iron, symbol for copper, symbol for lead, symbol for silver, symbol for gold, dear students, symbol for platinum, and symbol for mercury. But the problem lying with the Dalton symbols was, dear students, that it was very difficult for a person to remember the symbols like this. It was very much difficult for a person to remember these symbols. So these symbols were discarded as far as IUPAC nomenclature is concerned, as far as IUPAC, International Union of Pure and Applied Chemistry, is concerned. Nowadays, IUPAC approves names of elements. So you people are not in a state to memorize or to remember Dalton symbols nowadays, because IUPAC approves names of elements nowadays. So this was a symbol for hydrogen. carbon, oxygen, phosphor, sulfur, iron, copper, lead, silver, gold, platinum, and mercury, dear students. This was all about the symbols. After the Dalton, then came another scientist, that's Berzelius. Mark my words, dear students. Then came Berzelius, and he suggested that the symbols of elements be made from one or two letters of the name of the element, dear students. Mark my words. Berzelius suggested that the symbols of elements may be made from one or two letters of the name of the element. For example, this is boron. The symbol of boron is B. This was suggested by Berzelius. That's why I'm telling you, dear student, that Berzelius suggested that the symbols of elements be made from one or two letters of the name of the elements. Like carbon is symbolized as C. So nitrogen symbolized as N. We have hydrogen symbolized as H. We have sulfur symbolized as S. So this concept was given by scientist Berzelius. Berzelius suggested, he came after the Dalton because Dalton symbols were very difficult to remember. Now from that I can say from that period it was actually Berzelius suggested that the symbols of elements were made from one or two elements, letters of the name of the element. For example, boron is symbolized as B, carbon is symbolized as C, nitrogen as N, hydrogen as H, sulfur as S. So this was all about symbols proposed by Dalton and the Berzelius suggestion. And it later on it become very much easy for we people to remember these elements. So I hope you enjoyed this very lecture. In next video lecture, dear students, we are going to discuss regarding the modern symbols as far as periodic table is concerned, as far as 118 elements are concerned, and every single element is represented by its respect to symbol, and every symbol have been approved by an organization, that's IUPAC, that's International Union of, that's widely internationally accepted, that's International Union of Pure and Applied Chemistry. Stay safe and stay blessed. Allah bless you all, and thank you for watching this.